Okay, I'm going to teach you about 155 through 159. On 155, we're looking at a triangle that's a 45, 45, 90 triangle. You can know if it's a triangle that they add up to 180 degrees. So this one must be 90 degrees because 45 plus 45 makes 90, and then this must be 90. All right, so I have a 45, 45, 90 triangle. Now, as I'm thinking about these, I'm trying to think of a good way to make this make sense to you. But this 45-degree angle here is related to the side opposite from it over here. Okay? And the 45-degree angle here is related to this side opposite from it. And if you think about this, I think it'll make sense to you that since they're both 45-degree angles, then the length of the side over here, kind of related to that 45, and that 45, and this side here, those sides should be the same. Okay? I think it would just sort of make logical sense to you that they would be the same. And if they are the same, then you can say that if this is x, then this must be x. Okay? And they've already got the hypotenuse in here, so this is one of those triangles that you need to remember the relationship of the sides. Okay, on any 45, 45, 90, you can make a little sketch for yourself like this. This is 45, this is 45. That whatever this is, it'll be the same as this, and that the hypotenuse will always be that same number times the square root of 2. Okay? So that's one of those triangles that you should remember from geometry, and don't let that one go, because we're going to use it a lot too in the higher level math classes. All right, moving on to this one. This one is another really important one. It's the 30, 60, 90 triangle. Okay, again, these all add up to 180, so 90 plus 60 plus 30 adds up to 180. All the angles in a triangle will always do that. And the 30, 60, 90 one is special. It also is, it's got two things that are kind of easy to remember and one thing that's hard to remember. Okay, the shortest side in this and the longest side in the triangle, which is always the hypotenuse, are actually, one's double the other. Well, so obviously this one must be the one that's double. And that's double x, so that must be 2x. Okay, so that's what you should put there. Now this one is just a harder one to memorize, but if you have your 30 and your 60 and your 90, that you'll have the longest side is always twice the other side, 2x for this, and the shortest side makes sense, it should be over here, doesn't it? Because it's across from the 30 degrees, so it should be the smaller one, and that's x. And then you just have to remember the last one is also x, but it's got a root 3, x times root 3. Okay? Another important one as we move into trig and that kind of stuff. All right, moving on. Find the area of this triangle. Well, I thought we just did triangles a little while ago, and it was 1/2 base times height. Well, it still is. We do 1/2 times the base times the height. Well, it's just that our base isn't a nice simple number. Our base here is x plus 3. Okay, so I go 1/2 times the base is x plus 3, and our height is x. So then I multiply it out and say 1/2 times, I'm going to just kind of rearrange this here and say 1/2 times x plus 3. Just because I think it'll make more sense to you when I multiply this out like this. And I say 1/2 is still in the front times, I'm going to do this part next. X times x is x squared. X plus times 3 is 3x. Okay. And then I'm going to do the 1/2 of all of that is the same as if I did x squared plus 3x and I divided it by 2. That's one way I could write it. Or, from one of the other videos, you might know how to do this. I can take each part and divide it by 2. X squared over 2 plus 3x over 2. All right? So either way, that's the area of my triangle in this case. I can't figure it out any closer because I don't know anything more than what they've told me about the sides. So if I knew how long these sides were, it would have been easy. But since there's only giving it to me in terms of x, I have to leave my answer in terms of x too. All right. Next, the area of this circle. Well, always start with a formula if you can. And I know the formula for this. Area is pi times r squared. Okay, and then do I know the area? No, I don't. So I put A. Do I know what pi is? Yeah, I know what pi is. It's pi. I'm going to leave it as pi, though, instead of saying 3.14, because if I say 3.14, I'm estimating, and I'd rather leave my answer exact. So I'm just going to leave it as pi. And I know my radius squared, okay, my radius is x. So the area of this thing would be pi times x squared. And I know that's uncomfortable for some people to leave your answer with a variable in it, like x. But if they don't tell me what x is, then that's what I have to do. I have to leave my answer in terms of x and leave the x in the answer. Okay? All right. Next one. Find the dark area. All right. So this is a classic shape in a shape kind of question. And this is what we're trying to get at in this general kind of problem is if you have a shape inside another shape or two shapes added together to make a total, you just have to figure out both areas, okay? And so to find the dark area, I'm going to find the area of the big one and take away the area of the small one. So generally the big one minus the small one is my total, okay? The dark area is the big minus the small. Well, the area of the big one is 8 times 8, which is 64 centimeters squared. Don't forget those units. Minus the small area. The small area, you go 2 times 2 makes 4 centimeters squared. And so 64 minus 4 is 60 centimeters squared. All right? So a shape inside a shape is a classic question you're going to get asked a lot in geometry. That's all I